Thank you for having us. Great to be back here in New York. And I think this discussion is very timely to follow on to the last panel and talk about the journey to 5G. It's certainly not a short haul trip, but will be a path over the course of time with various implications as it relates to spectrum and technology. And so we wanted to talk a little bit today to address some of the myths about 5G and what it really means for indoors. I have my colleague here with me, Roger Galuban, to help talk through some of these things.
Thanks, Lori. Yeah, so we've heard, I think, this morning a lot of good conversation on 5G and demands from some of the folks coming into your properties, asking, sometimes even demanding, can I get a guarantee that whatever system is deployed in this building will support 5G? And so it'll be really interesting to talk through and get some of your questions as well as to what does it mean to provide that 5G service. There are a lot of products obviously coming into market, but 5G, the way we see it, it's truly a journey. It's an evolution. We're just starting on that path, and there's a variety of different solutions and the different spectrum assets that exist and are coming on board as we started even with the CBRS conversation this morning. And so we hope to go through some of that journey and have a good conversation as to how can the 5G system be deployed in a good way, meeting the different needs depending on different properties.
Yes, absolutely. And as we heard one of the gentlemen saying last, there's situations where I think some building owner executives are thinking, okay, well, let's get 5G in our building and be one of the first to have 5G. But as we've discussed before, I think it's a matter of, okay, what's really the application? What are we trying to solve for? What's the use case? And there may be things we can more easily do and accomplish today, but have that upgrade path to 5G, and certainly spectrum implicates that as well.
Right. So maybe we'll just get started about what really is 5G, and from a radio access technology perspective, 5G NR as defined by the 3GPP is just that. It provides you with additional capabilities from the speed of access or that network would provide to end user devices or applications where clearly LTE was not able to support and provide. But there's also some new spectrum that is becoming available that is dedicated to 5G. And that's maybe one of the myths that exists today, is that people think millimeter wave sometimes when they think 5G. And the two, while certainly have a good connection, it's not the only way of providing 5G service. 5G can be provided, and it has been approved in the 3GPP standards on a variety of different bands, including low bands. So our operators here in the US, Verizon, AT&T, T-Mobile, Sprint, all of them who have low band spectrum assets can turn on 5G service on that spectrum as soon as their strategy is aligned to that, right? So each operator will have their own strategy as to where they want to deploy 5G services on the different assets, spectrum assets they have.
So along those lines, Roger, I've been hearing some lately about something called dynamic spectrum sharing that I think applies to these lower and mid-band spectrum assets. Can you tell us a little bit how that's working and how that can help address the upgradability?
Yeah, so this is one of the recent adds to the 3GPP specification on 5G is this concept of dynamic spectrum sharing, where a radio that today supports 4G LTE through a software upgrade, or maybe a newer radio if the older radio was not able to support that capability, will be able to serve customers both on 4G and 5G on the exact same radio and exact same spectrum. So let's take, for example, a deployment where AWS and PCS, which are very common bands here in the US, are deployed inside your building, and you have a system of based on radios and basebands where that capability can be turned on. So with the software upgrade, you simply enable dynamic spectrum sharing, and the network intelligently or dynamically, hence the feature name, will assign its resources to serve 4G and 5G devices. So as over time, more 5G devices enter the premises of that network, the 5G service starts to take a little bigger chunk of the scheduling, and hence being able to provide the 5G coverage and capacity in 4G slice we see over time being reduced. That's a little bit different than what was done from the previous 3G to 4G transition, as some of us who were around then may recall that operators would statically refarm their spectrum. So if you had 20 megahertz that was serving a WCDMA or UMTS network, you decide, okay, well, let me assign 5 megahertz of that to LTE and keep 15 megahertz to WCDMA, and over time start increasing the slice to 4G and reducing on 3G until that went away. Now with dynamic spectrum sharing, you don't need to do that from a planning perspective. You just turn on the feature and the network will dynamically serve customers on both technologies.
Okay, very good. So I guess just to kind of highlight that, two takeaways. If a building has a system deployed today or in the near future that supports a 5G NR software upgrade capability, and the wireless operator incorporates this into their strategy, they could very well have 5G service in that building via a simple software upgrade in those bands.
Exactly. So that really helps from an investment perspective. If you are a building owner, understanding that this particular system is fully upgradable to 5G. I don't need to rip and replace a year from now or a few months from now when I want to enable 5G service, or when the operator says, okay, now AWS, PCS, or even a low band, we want to turn 5G on that spectrum. Well, the radio and baseband can be upgraded via software, right? So no new investment or no rip and replace required.
Okay, very good. Because as we were talking, some of the other panelists had said as well, with millimeter wave may not initially anyway be as relevant for, say, a commercial office building as it would be for, say, a stadium or airport or big, large open venue. So can you talk about some of the limitations of millimeter wave and then how it is a game changer for the larger venues?
Absolutely. So one of the big benefits of millimeter wave spectrum that has become available, and why it's brought in billions of dollars of investment from the carriers as the FCC auction off the spectrum on 28 gigahertz, 39 gigahertz, and more recently 24 gigahertz. Is the wide amount of bandwidth that it provides. So it's of great interest. Well, if in the past I had, let's say, 15 megahertz on AWS or PCS, and now all of a sudden I have 400 megahertz available on a high band, that's huge capacity that I can make available for high capacity or high demanding venues, right? So think of a stadium application where you have large concentration of subscribers, all of them trying to use their social media applications, whether it's your Facebook Live or Instagram with video and posting on their stories and making their friends jealous. Oh, I'm here at this game or at this particular show. That particular application demands a lot of network resources, and 15 megahertz on AWS may not be enough, but all of a sudden I have now 400 megahertz of millimeter wave available and with advanced antenna technology such as beamforming, really focusing that capacity to where the devices are demanding at a particular point in time, millimeter wave is very attractive in these high demand locations or high capacity venues. So stadium applications, convention centers, maybe transit stations where you also have a lot of people coming and going. Obviously, a metro area like New York City is great for millimeter application, also on the street level side. But when it comes to office space, regular office space, do you really need that much capacity where people are sitting at their desks and using their laptops or whatever application, maybe a voice application? We don't quite see that millimeter wave is required, and you can actually make a business case for the investment of millimeter wave deployment in these standard office or even residential type of applications at this point in time.
Yeah, so perhaps on that note, over time, as this journey progresses, as we heard from the last panelist, there is a lot more innovation beginning around prop tech, smart building, intelligent building technologies, where you may ultimately have massive amounts of IoT and significant density of devices. So do you think maybe over time it could become applicable with those applications?
Certainly, but it really also depends on the amount of data those devices are requiring, because even if you have a large amount of devices, but those devices are not transmitting huge volumes of data, you're still able to serve those applications with your low and mid-band spectrum. So there's still a lot of mileage that we can, I think, take from existing networks on the low band before you need to go to a millimeter wave type of application. And speaking of narrowband IoT applications on millimeter wave, there's still a whole ecosystem that needs to develop to get there. The first applications are clearly focused on fixed wireless access, and then now with mobile devices, and you see some of the debate in the industry, even amongst operators, how 5G with millimeter wave provides great solution, but in a relatively restricted area, right? So for a nationwide coverage 5G solution, you want to look into your low band and mid-band spectrum to be able to provide that experience across the nation. Yeah.
So perhaps layers of technology, so to speak.
Absolutely.
And getting back to the stadium application, that's something that we've talked about before, is actually having these layers of different technologies. Can you kind of describe how that looks?
Yeah, so in a stadium application, you typically find that all of them will have DAS systems installed with the antennas pointing towards the field, towards the center of the whether it's an arena or over a large NFL venue or even a baseball stadium. And what we typically find is that the directionality of those antennas towards the center tend to cause a lot of interference closer to the bull. And as you try to add more capacity, typically folks think about, well, let me add more sectors and then add more antennas, and you help with your capacity on the outer area of the stadium, but you actually end up causing more interference towards the center. And going back to the layering approach, what we see is that if you have less amount of sectors on your lower band, so you provide that base coverage layer with a DAS system, you can actually then layer that on your mid-band, maybe with a lower power solution closer to where the subscriber is, as opposed to shooting high power directional antennas from the top, such as under the seat applications, which I'm sure some of you guys may have heard about being done recently by some operators, whether it's with direct antennas being positioned under the seat, whether small cells or distributed architecture. Those seem to be able to provide much higher capacity to stadium type of applications with LTE. And then, of course, if that infrastructure is upgradable to 5G NR through a software upgrade, it's that much more valuable to stadium owners, so they don't have to constantly be ripping and replace that infrastructure as frequently.
Right. So I think even with the evolution of what's possible with LTE, there are some ways to accomplish very high capacity and throughput on the systems, correct, with 4x4 MIMO capabilities and things such as that.
Exactly. So certainly the LTE Advanced standards provide huge capacity even today. And let's be frank, most of subscribers today is still carrying 4G capable phones. The 5G phones are just starting to come out now, but it will still take a while until that ecosystem is fully developed, and the networks then need to be able to obviously provide and serve those users in the future. But with LTE Advanced, we are able to see gigabit plus performances today, even with AWS, PCS, and some of the low bands in carrier aggregation and using 4x4 MIMO, as you said. And then if you add CBRS on top of that for the operators that don't have more mid-band spectrum assets today, they are certainly able to approach close to 2 gigabits per second on LTE Advanced. We've done a project recently with one of our operators, major operators here in the US, where we did aggregation of AWS, PCS, and CBRS just using 3 radios, 4x4 MIMO, and we got 1.4 gigabits per second. So as you add more carriers of CBRS, and as you know, 150 megahertz is becoming available with ICD, hopefully happening in a couple of weeks, that kickoff of ICD in DC. So that is significant spectrum assets that will now be able to provide very high throughput to end users using LTE Advanced today.
So it sounds like it's really a matter of what are the applications, what are the outcomes we're trying to achieve, and what technology spectrum's available to do that, both in the short term and as we can progress over the longer term. And I believe there was also, it was recently in the news where Ericsson worked with an operator over in Europe for a 5G indoor deployment. And so can you tell us how that was working? Because it seems like there are kind of limited reference cases so far about 5G deployed indoors. Yeah,
so 5G indoors is definitely here. So not to make this a sales pitch, but we do have 5G indoor radio products that have been deployed. To the reference you mentioned with Swisscom in Europe, a little bit different in Europe than in the US, where in fact, most other parts of the world where the 3.5 spectrum has been auctioned and allocated for 5G NR exclusively in some countries, as opposed to a CBRS play that we have here in the US. So because we have a 3.5 radio dot system is what we call our small cells product, ready to support CBRS and 5G. That was done with Swisscom a few months back. And yeah, they have that network up and running in Switzerland today, providing 5G services on 3.5. So it's certainly happening. We have seen a shift in some of our sales of products. Obviously, a huge increase on 5G uptake. Macro network goes without saying, but certainly from an in-building perspective, in markets where 5G spectrum has been made available in the mid-band spectrum, products are really being deployed at a fast pace in preparation for consumers starting migrating their devices over to 5G.
And I understand, as you mentioned, the CBRS launch coming soon, but what about the plans underway to have 5G in our standards for the CBRS spectrum band?
Right. So I think that was really well covered in the talk earlier this morning with our friend from Google, Andy, and I think it's a work item today that is expected by the WIN Forum and CBRS Alliance to be completed by the end of the year. 3GPP has already assigned and 48 as the band for CBRS. So as soon as that is ratified and completed, and devices start to support CBRS band, from an infrastructure perspective, most radios being deployed with CBRS should be easily upgradable. That's the expectation anyway. Certainly, I encourage everybody who is looking at purchasing CBRS radios and deploying those solutions, ask whoever's providing that solution, will that be upgradable to 5G, right? You don't want to be locked in a situation where you're deploying radios now and next year when 5G standardized, oops, need to rip and replace. Ideally, you want to deploy the radio once and be able to do a software upgrade to 5G on a CBRS when it comes next year.
So it sounds like with all of these technology options and the journey of this evolution, it's really about having the upgrade ability, maybe some expandability, to evolve with that over time.
Right. I think that's key, right? If I'm going to invest in a solution to provide 4G services today, I want to be able to have some security that solution will lead to a 5G network tomorrow with the software upgrade. I don't want to be ripping and replacing every time there is a technology shift, especially if it's just another radio access technology using the same spectrum. So as soon as Verizon, AT&T, T-Mobile decide we're going to turn on 5G on AWS and PCS, the ideal solution, I think, being deployed today should provide a software upgrade in those spectrum bands, right? Or even low bands, although typically we don't see as a high, I would say, deployment of low bands for in-building applications, as typically you can get some signal from outside-in coverage from low bands, and so most in-buildings tend to be more on the mid-band, or I should say 2 gigahertz higher, right? So AWS, PCS, or 2.5, today's Sprint, and I guess in merger talks, maybe a new T-Mobile in the future. But yeah, those tend to be ideal spectrum assets for in-building today.
Okay, excellent. So sounds like maybe more 5G options than we realized besides millimeter wave. Okay,
For
very
sure.
good. Well, I think I'll open it up to see if anyone from the audience may have a question.
I'm going to actually start this one out on our own because Mark Hewitt is tuning into our live broadcast right now, and he sent in a really good question that I thought would be a nice way to kick off the Q&A. But Mark asked what the new density is actually doing to the GPS or the location resolution for a customer's devices, and I thought that would be a nice place to start.
Yep.
Excellent. So,
No,
you
go
mind
ahead.
if I'll take that. So location-based services is definitely a big deal. If you think of stadium applications or even from a public safety perspective. Some of the small cells products that we are developing now, we are building in what we call hyperlocation, where you can locate a subscriber within a 2-meter range of that small cell radio. Now, obviously, that does require a small cell deployment, right? It's a little hard if you're distributing that signal over a DAS infrastructure because now you're repeating that and so many different antenna points for you to actually be able to locate the user without using other technologies such as, there are many technologies that are added even with Wi-Fi today, whether it's BLU or Bluetooth variant or others where you can ping the device. But certainly from LTE or 5G NR capability, small cells products very soon will be able to locate users very precisely.
Excellent. And Mark, thank you for tuning in, and thank you for the question. Any other questions here in the group? Don't be shy. Back over here on this side, sure.
Thank you. Could you talk a little bit about your Erickson Dot Technology and how that might work both currently and in 5G?
Absolutely. So I'm actually one of the product managers for the radio dot system. So very happy to talk to you all day long about that product. So the radio dot is basically a two-tier architecture where you have the radio intelligence divided into components. You have an actual radio dot that looks like almost like a Wi-Fi access point, other than it's round as opposed to square. And you typically would install in a drop ceiling. It's about a little bit under a pound in weight, and you provide the signal and power over a Cat 6A infrastructure. Because it is a proprietary interface, we can drive that Cat 6A length from the radio units to the actual radio dots to 200 meters or 600 feet, which is about double what you get on your typical digital interface today in your IT infrastructure, right? So that tends to be one of the appealing factors, is that you can deploy less equipment and require less closet space distributed in your buildings with a radio dot system deployment. And running Cat 6A infrastructure is relatively inexpensive compared to some of the coaxial infrastructure that we deal today, or even fiber for that matter. So the other part of the architecture is the indoor, what we call an indoor radio unit, where you can connect today up to 8 dots. And we're launching a product actually next month that will have a 16-port indoor radio unit, so you can connect up to 16 dots on that indoor radio unit. Each dot today provides up to 2 frequency bands of spectrum that can be used. We're working for next year on triple and quad band dots, where you'll be able to support much more spectrum on a single one. The one that we deployed with Swisscom that Lori was referring to, the 3.5, it supports up to 100 megahertz of NR on 4x4 MIMO. So on that single dot, you can get up to 1.5, 1.6 gigabits per second of downlink throughput. And let me see, what else can I tell you about? I mean, here in the US, it has been quite popular. It has been approved by all the major operators. All of them have deployments with the radio dot throughout the nation. And we also have projects where they're being deployed now in multi-operator environments. So we're very excited about the product, not only because it has been around now for a few years providing 4G, but the fact that it is software upgradable to 5G. So any radio dots that are out there when 5G is required by the operators, or they have a strategy to turn on 5G in, say, AWS PCS, all existing dots will be software upgradable with that.
Yeah, I'll just add on the baseband, that's the part of the architecture, is using the same technology as what's in the macro network. So it has the same set of software, parity and features. It can receive those same upgrades over the network, including the upgrade to 5G NR.
Yep, good point.
First of all, thank you for doing this, and it's an honor to meet you all. Actually, I know or heard your name at some point, but it's really good.
Thank you.
I wanted to ask you, actually, DOT product, I have used that quite a lot, and I saw the limitation. You already told some of them a roadmap that you have, but on top of that, because of its power limitation or whatever the case is, on a neutral host scenario or something, it's been a challenge, and I cannot propose something instead of a neutral host, use DOT. That's one thing. And the other question I had, that when you have CBRS or other spectrum or technologies adding, is there a roadmap for carrier aggregation on that to make it better bandwidth and essentially better throughput on that?
Sure. Maybe I'll start with the CBRS question. So we do have a CBRS dot today that is being deployed by, I think, a few carriers just in preparation for the initial commercial deployment coming in a couple of weeks. And yes, you can aggregate CBRS, do a carrier aggregation with CBRS and your licensed spectrum. That is fully supported, as Lori said, from the Ericsson baseband. So whether you're doing that in our macro network or micro radio products, small cell outdoor products, or indoor with the radio dot, that's fully supported. As far as neutral host, which I think is a very good discussion to be had, there is a new component in the architecture that we're adding early next year. It will be available for trials actually at the end of this year with our operator customers, is the ability for you to inject an external RF source into a deployed radio dot system. So it almost, I would say, somewhat similar to what a DAS system, where you would enable other operators to bring in RF signals from other source and reuse the infrastructure. The radio dot system will provide that same capability. So you can, for example, deploy radio dot on AWS and PCS, which are common bands for most operators here in the US, and then have different operators join in that infrastructure, either through an Ericsson baseband, say the primary operator for that building, for example, could be AT&T, Verizon, T-Mobile, and then a second, third, fourth operators could join in that infrastructure with separate RF signals, whether from Ericsson radio or from a different vendor's radio as well. That will be fully supported, right? So it becomes closer to a neutral host multi-operator deployment at that point in time. So as I said, we'll be ready for trials end of this year. Okay. Does that help? Okay.
Unfortunately, that puts us at our time.
All right,
I wish
perfect.
it wasn't, but
Thank you.
I want to thank Lori and Roger so much, and thanks to Ericsson for allowing you guys to be with us here. Really appreciate it. Everybody, nice round of applause.
Thank you, everyone.